Oh, wait, it's about to fall. Ah, there we go. Beautiful.
So you just have to push.
Press and hold?
Yeah, and just short bursts.
Oh, I see. Yeah, and yeah, I haven't shown you yet. There's the door to get inside.
Oh wow!
So, yeah, it's just springs and it's yeah,
Okay.
yeah. Unfortunately, because of how flimsy the plexiglass is, don't want to release it too hard. But
Wow.
yeah, and there's the hole for the pitot tube to insert.
There's smoke.
Oh, oh, you remember how that went earlier? Yeah.
Somebody say we got smoke. It's the button stuck. Oh wow. Smoke generator is a nice effect.
That helps so much actually.
Now we'll crack that lid open a little bit. Let's see if we can,
Here?
Oh, yeah, right there. Just crack it open a little bit. Let's see if we can see the air. Tell that the air is flowing in. See what it's doing to the airflow?
Yes. Yes.
Because it's moving, air is going to go in there. It's lower pressure.
Right. So look at that. Yep. Exactly. Wow. Wow, no. So, how do you adjust the flow rate of the smoke?
Right, so there's a, just this can is just a pressurized can with liquid in it.
Okay.
That vaporizes. And there's a heating element that gets really hot and burns this.
Right. Right. Do it again, Ray. Yes. Now, I could never have talked about this in class, or to give students an image of this happening in the
And like
classroom.
this device could be sold like as a standalone thing, honestly.
Your little fan controller?
Yeah. Add any other peripherals you want to it. Just SD card slot on the side or anything.
So if we added an analog channel to it, we could have added a pressure transducer.
Yeah, there are analog pins on the Arduino.
Right. So if we got a sensitive enough pressure transducer, it can read the manometer.
Okay.
You know, that little handheld one that those guys got to use, well, it's got a sensitive pressure transducer, and then it's got an Arduino in there, or, you know,
something
the
like that.
1980s versions to take the voltage and turn it into
pressure.
To the information you want to read, yeah.
That's kind of like how the thermocouple works, right? Just the difference in temperature produces a voltage.
Yes.
Oh, okay.
So, yeah, thermocouple is Seebeck effect.
Okay.
Warm up a joint made out of two different metals. They start sharing electrons.
Okay.
When you're trading electrons, we call that an electrical signal. Now you have to have a voltmeter, so a thermocouple has to be read by a voltmeter with super duper high resistance, so it can see that the electrons moves, but it doesn't use any. Because otherwise you'd make the signal go away.
Oh, okay.
And it's not a linear effect, but it's a shallow curve. You know, if it was a straight line, you know, temperature change equals voltage change. Here it's a little swoop.
So I have the wire, the other end, the 2 leads hooked up to like a little module, and then that hooked up to my
Right,
Arduino. So
that's-
that does all that work.
Yeah,
that module does.
Basically, what it does is it's a micro volt reader with a map in it that says if you see this voltage, it means that number. If you see slightly different voltage, it means a different number. It has
Okay.
a lookup table in it.
Okay.
And then the good ones have more room for more spots on the curve. The cheap ones have fewer spots on the curve.
Okay.
And then there's also something called cold touch.
That's still fresh, by the way.
Yeah, I don't. Well, that should have been duct tape. That would have been the right way to go.
Whoops.
That's I know.